Welcome to the tutorial video for SysCall 2 within the JaeOS operating system under the MicroARM emulator. The purpose of SysCall 2 is process termination, to delete a node and all of its children using the functions that you defined in phase 1 of the project. The first step of SysCall 2 is to call a recursive helper function. This is a head recursive function, so after the base case, the second step is to call the function again. The base case is really simple. We don't want to be deleting nodes if we don't have any, so we just check if there is another node. Killing a process is a bit more involved than just freeing the control block. We need to make sure there are no remaining references to it, so no dangling pointers, and that any semaphore information remains accurate through each recursive call. Lucky for you, you've already handled the finer granularity in the phase 1 functions, so the process here is relatively straightforward. You want to ask 3 questions. First, is the process blocked? So is it waiting on a semaphore for something? If it's not blocked, then is it on the ready queue? And if it's not on the ready queue and it's not blocked, then it must be the current process. We'll start with the most complicated, if it's blocked on a semaphore. First thing you do is unblock it. That's easy. But we have some variables associated with semaphores that need to be updated. We'll start with the second case first, if it's not on a device. Very simply, we simulate a signal. It's important that you're not calling sys3 because we're going to be deleting this node. So we don't worry about whether this is an unblocking signal or not, nor do we want to put it back on the ready queue because it's going to be dead after this call. In the other case, if the node is waiting on a device, it's a little bit different. We need to decrement soft block count because that's the number of processes waiting on devices, and the scheduler needs that number to be accurate because it's going to make a decision based on this value. And that's all. We don't want to simulate a signal if it's blocked on a device. And the reason for that is, if a process is waiting on a device, that means there's a pending interrupt. And since there's a pending interrupt, when this syscall ends, we're going to go straight to the interrupt handler, and the interrupt handler is going to perform a signal. So if we did this here, we would be signaling twice when we really shouldn't be. Let's look at the other 2 cases now. If it's not on a semaphore, then it might be on the ready queue. To remedy that, we just take it off the ready queue. It really is that simple. If it's not on the ready queue and it's not blocked, then the only place it could be is the current process. Now if it's the current process, the only references that might exist to it are in any parent nodes it might have. Now it might not have a parent, but just in case it does, we'll remove it from any parent that it might have. And of course, finally, we want to deallocate the node, so return to the free list, and obviously decrement process count because we're down 1 process now. Outside of the recursive call, we need to set the current process to null because it's gone. And since we have no process now to load to, we need to call the scheduler. It needs to find us a new process to run. And that is the entirety of SysCall 2.